Okay, dear students, in the last class actually we have gone through the various historical developments of the material science and engineering, and there we have seen what's the basic difference between a material science engineer as well as a material scientist. Okay, in this class we are going to see the next part, that is the important components of material science and engineering. Here in this part actually we will see the important components, and the material science and engineering having four major components. The first one is processing, second one is structure, third one is properties, and the fourth one is the performance. Okay, and you can see an arrow mark showing like this because this indicates that the performance is a function of properties, and the properties are function of a structure, and structure is in turn the function of the processing. So this is a very important topic, and you can expect some university questions university as well as some serious questions from this area. Some major questions that you can find is like explain the structure property relationship of a particular component or particular element or something like that will be asked. And now let's see one by one. Like we will begin with the structural component. Okay, so structure actually refers to the arrangement of the internal components or the internal matter of a particular material. Okay, you can see that like it is basically classified into subatomic structure. When the size is increased, like you can see it is an atomic structure. Again, when size is increased, it will be like microscopic structure, and finally with the macroscopic structure, and sorry, this one is microscopic structure, and finally last one is the macroscopic structure. Okay, coming to the subatomic structure, I think you all have studied it in your basic school level thing. Like every material is made up of subatomic or atomic particles. So the subatomic particles, what do you mean by subatomic particles? That means the particle within an atom. Okay, so the structure deals with the subatomic particles is known as subatomic structure. Actually, the subatomic structure consists of three parts. Like the first one is known as electrons, which revolves around the nucleus, and within the nucleus it is divided into two, that is proton, which is positively charged, and neutron, which is of neutral charge. Okay, so that's about the subatomic structure. And those electrons on the valence shell has got a significant role in controlling the reactivity, emissivity, and such kind of properties of material. So the study of subatomic structure is very critical, and like since higher amount of magnification is needed, and until now no such magnification is there, and no one have seen these electrons and protons, like we can feel or we can detect these subatomic particles. So various conceptual models are available nowadays. Next one is the atomic structure. In atomic structure, it is the arrangement of the atoms within a material, or arrangement of a certain amount of molecules within a element. So that kind of structure or the study of such kind of arrangement is known as atomic structure studies or atomic structure. Okay, regarding the reactivity, regarding the appearance, regarding the strength and various properties, all depends upon these atomic structure. Like for example, I am telling that just imagine carbon and graphite, both are made of same element, that is carbon. The graphite as well as the diamond, both are made of same element, then how it looks different? Graphite has no relation or no similarity with the diamond, but it's all lies with the atomic structure. Certain arrangement of the carbon, one kind of arrangement is there for the diamond and another kind of arrangement is there for the graphite. That's the basic difference. Okay. Next one is the microscopic structure. Here we analyze the material with the help of higher magnification microscopes. Okay, higher magnification or higher resolution microscopes are SEM and TEM, scanning electron microscope and transmission electron microscope. Okay, these are not the ordinary microscopes which you have seen in your high school laboratories. It's entirely different. So such knowledge or such equipments are used to evaluate the microscopic level studies. Okay, up to nano level we can study with the help of scanning electron microscopes and transmission electron microscopes. Okay, so next one is the macroscopic structure. That means here we use our naked eye or a higher magnifying glasses to evaluate the structure or the arrangement of any element. Okay, so that's what the structure of a material deals with. And next is the crystallography. Crystallography is the branch which deals with the arrangement of the atoms within a crystalline solid. Okay, this arrangement, those people who are assigned to study this arrangement of atoms are known as crystallographers. Okay, the significance is that sometimes, like, you got a metal and you don't know which metal is that. Okay, so what you will do is that you will directly take this metal and give it to some crystallographers, and they will subject it to some kind of study, and they will finally they will tell that, okay, this is that element or that material, that particular material. So that's the proof, or that's the role of the crystallographers. Oh, how the crystallographers identify this? Okay, they don't have any other magical powers, but they depend on some techniques or some equipments like X-ray diffraction, neutron diffraction, and electron diffraction techniques, and to identify these crystalline structures, and finally they will determine which material it is. Okay, they also assign to improve the crystalline structures or improve the properties by adding some new materials or some with the help of some kind of process. Okay. Now moving to the next component, that is the property. Here what we will do is that we will apply an external stimuli. Okay, property is that external stimuli which evokes some kind of response from the material. Okay, like if you just take a hammer and if you hit it on the wall, what will happen? Okay, the crack will occur. Okay, so the hitting is that external stimuli and the crack is known as the response. Like a specimen is subjected to force, say tensile force, so it will experience some kind of deformation or a crack. Okay, when you are hungry, okay, the hunger is another external stimuli, and the eating tendency, when you eat, that is the response which you have given. Okay, so there are 6 different category of properties are there. The first one is mechanical, second is electrical, third is thermal, fourth magnetic, optical, and deteriorative properties. Okay, the examples are also given in this column. This column represents the stimulus, that is for mechanical, elastic modulus is the example, and the stimulus is the load or the force which is applied. And what's the response? Response is the deformation. Similarly, if you are seeing an electrical property, electrical field is the stimulus and the response is the current or voltage. I request everyone to pause the video at this moment Okay, don't see, because these answers are there in the next slide. So just pause the video, just search in the internet for these properties or with these examples, and try to find the stimulus and response. Okay, it is to just to improve your knowledge regarding this subject, because I am giving you some kind of small. This is not an assignment. Don't consider this as an assignment. Just go to your internet. This will improve your research abilities, so that you will get much interest to this subject, and you will, at the end, you will feel this subject as very, very light. Okay, and moreover, when you search for this kind of things, you will come across many different interesting case studies also. So that will improve your, what to say, that case study data bank in your memory. That will help you a lot in your examinations. Okay, so that's the property of a material. So this is the solutions, or this is the answers. So I think everyone have searched and might have got different answers. No issues for those one. Like here, one property is the chemical reactivity. Chemical reactivity, it is the chemical reaction is the stimulus, and the response is the byproducts. And optical property, the stimulus is the electromagnetic or light radiations, and the response will be like, it can be different response. If you apply it to a certain sensor, like to produce some kind of heat, it will produce it, light sensing, etc. Okay, so these are the various properties, stimulus and corresponding responses. Okay, now let's see the this thing, like structure property performance relationship. Okay. That means the performance of any object or a material depends on its properties. And how these properties depends on the structure, and the structure depends on the processing. So they are interconnected. Okay, so in other terms, you can call the material performance as a function of material properties. And material properties is another function of material structure, and material structure is another property of another function of this process. If you take the hardened steel, you can see that the hardened steel performance purely depend on its properties. The properties depends on the internal molecular structure or arrangements, and the structure in turn depends on the process, in which process it is manufactured. So this is the class assignment that you need to do and submit it for your attendance and to improve your idea. So the class assignment is like this. You just need to compare the performance. Okay, performance of a handmade versus machine made walking sticks. Okay, the walking sticks, you all know, at the elderly ages we all need this support. Okay, better during that time we will feel some comfort in these walking sticks rather than our relatives. So better don't avoid such things. So make a performance evaluation just now itself. So it will be very good for all of us. So just see which one is good. Okay, a machine made or a handmade, both will have pros and cons. You can anyway you can have that kind of studies. So next is the this is a case study kind of thing. This is the design of high strength steels. Before design, like we will make such a kind of flow chart. Here it represents the performance, and next tab is the properties which mainly deals with the strength, toughness and hydrogen resistance. Sorry. And these properties in turn depends on the various structures. You can go through these tabs. You can read these tabs and you will get an idea how these strength depends, or these various properties depends on the structures. And in fact, these structures, how it is made. It is made by various processes or the combination of various processes, not all together, some process. So in turn this process determines what the structure should be, and the structure determines how the property should be, and these properties will decide how an element or an material should perform. Okay. So this is the significance of the material science and engineering. It is basically an interdisciplinary area which contains many, like civil, mechanical, electronics, electrical, chemistry, nanotechnology, physics, even logistics, management. Many are there. So it is an interdisciplinary area. So here, what you do is that you need some knowledge of what you need to select a proper material from the database of some thousand materials available. Okay, and what you will do, you will apply it at the proper place. Also, you need another knowledge, like knowledge of deterioration of material, like how long a material will be used. Okay, if it is for a small short term application, you can use some kind of polymer rather than using some steel or something. Okay, it is a corrosive environment, better avoid steel, or like better avoid iron. You can use stainless steel or some kind of some other kind, but it is somewhat expensive. You need to take care of that. That means you need to consider your economic aspects also. It should be balanced totally. Quality of the material, economic aspects, all depends on the all depends on your knowledge. Like, see, if you are selecting a material for a space shuttle, you cannot compromise the cost. There you need to uplift, or you need to give more weightage to the deterioration of material and selection of the right material. Here, there you cannot go for these economic aspects. Like some for some local uses, some your local products, if you are making for a budget level equipments or budget level products you are making, you don't need to think about this quality and about the right material. You can think much about the economic aspects. So depend upon the application, material science engineer will select the right material. Okay. So that's the significance. So with this I am concluding, and I am concluding this section, and in the next section we will see the classification of materials, how it is. It's also an important section. So by this I am winding up. Thank you for the attention.